Hi, in this video we're going to be talking about how to use the JDBC DSLink in DSA, and then how to get that data into DGLux and do further processing on it. JDBC is Java's connectivity framework into databases. Pretty much every single database out there has a JDBC driver in the form of a jar file that is available for you to connect to it. A very quick list of databases is here. You can see this on the DevX site. And you can see the drivers and databases that are supported, as well as their connection string templates. In this example and tutorial, we're actually going to be going over and connecting to Amazon's Redshift database. It's an extremely scalable database. It's based on Postgres, and it's cloud hosted, so it makes it very easy for us to do a tutorial on this. So the first thing we'd like to do is to install the JDBC DSLink. So let's expand System, go to Links, right-click and say Install Link, and we'll just type in JDBC and choose JDBC here from the list. So I'll click twice. That's why we have this error. But now that the JDBC DSLink is installed, we can go ahead and start it. Once we start it, it's going to show up for us right over here under the downstream section, and you can see that right here. So next thing to do is to right-click it and add a connection. So this is very typical JDBC connection string setting. So we're going to give it a name, as we're going to see this under the JDBC node. We can of course connect to multiple databases. We'll give it the JDBC connection string, username, password, and then we'll choose the driver to use. Now by default, you can see that the JDBC DSLink comes with two JDBC drivers that we can actually redistribute, which is MySQL as well as Postgres. However, for databases like Oracle, Microsoft SQL Server, or Amazon Redshift, you typically have to accept an agreement to actually download that specific JDBC driver. So the process of doing that is very simple. We're going to go into our Redshift console, and what we were doing is we're literally following this getting started with Amazon Redshift instructions. So we've gone through step 1, 2, 3, and we've actually already loaded all the sample data into the server. So at this point, what we're doing is we're actually just connecting to our Redshift instance, and this is our Redshift instance that you can see here. And I'm going to go here to connect the client, and you can see we can select the JDBC driver to download and install. So we're going to select JDBC 4.1, download that, and we'll keep it. And now you can see that we have it available in downloads folder. So I'm going to Command C it to copy it. And DSA is installed on my desktop under DSA, and I'm going to navigate to the DSLinks folder because that's where the JDBC DSLink is. And what I have to do is I have to actually copy that JDBC driver jar file into the lib folder. So I'll just go ahead and I'll paste that item in here, and you can see now the Redshift JDBC driver is here. Now for that to take effect and for us to actually see it, it needs to be registered, and that happens when the DSLink restarts. So let's navigate back to the JDBC DSLink. Right-click, restart the link, and you will see that now when we go to add connection, this actually shows up for us. So let's give this a name. Let's call this Redshift. And now we need to put in the URL, which is a connection string. So if I go to my Redshift dashboard in my cluster, we can see that this actually gives us a JDBC URL. I can literally copy it and paste this in here. And as I mentioned earlier, every single database is going to have a slightly differently formatted connection string. And again, you can see some of the examples here on DevX, and you can see just the subtle differences between how you connect, which ports are supplied, and other options and parameters. So we pasted that in there. Now I'm going to plug in the credentials that were set up for this. And when you set up your own Redshift database, if you're following this tutorial, you will be setting up your own credentials as part of the wizard. And for this example, we'll turn off poolable, but if poolable is true, it's going to be using a connection pool, and for larger installations, this is something that you probably want to turn on. For this example, we're just going to go raw JDBC right into Redshift. So once we've invoked that, you can see we have a Redshift entry here. And now we're able to right-click it, of course, edit the connection, execute queries, as well as delete the connection. So now it's time for us to test our query. I'm going to go back to the Getting Started guide, and in the Step 5 section, you can see we've already inserted all of our sample data, and then it gives us examples of some queries to run. So let's take this first query where we're going to get the definition for the sales table. Let's just paste that in here, press invoke, and you can see that here's all our data that was returned. Now the metrics also show us how many rows were returned. If we do slightly more complicated query, let's take this query that gets all the events in the 99th percentile in terms of all time gross sales. We can paste that in here as well, and you can see now here's that data. So now I'd like to show you what you're going to do with this data when you're bringing and how you would bring this into DGLux. The first example I'd like to show you is, let's make a pie chart from those columns that we just saw. So I'm going to go ahead, I'm going to create a brand new dashboard. I'm going to right click, go to its data flow. I'm going to right click on Redshift and take this query action parameter and literally drop it right onto the dashboard's data flow. What I can do here is I can create a string block, and this is going to hold our query. Because our query is multi-line, I don't really want to format it. So I'll just go ahead and I'll paste that in here, and we can link this block right into the SQL input. If I turn on auto run, we will see that now we get a table that's returned to us. So for readability's sake, we can go ahead and add this table block here, and let's link the output table to this. Let's call this sales data, and let's rename this to SQL query. Now, for those of you that are catching on of what we're doing, this Redshift database is massively scalable database that is available at a very fixed hourly cost. That means you are now able to ingest as well as visualize massive amounts of data without really any upfront investment. Okay, so now it's time to move on. We have our sales data table. Let's bring that up. And what I'd like to do now is right click, insert a chart component, and drop in this total price column. And we'll select a series to be a pie series, and we'll say that we will actually, the angular axis is going to be total price. So you can see now we're visualizing all of this data that's coming back from the database. Now as the next step, what we'd like to do is we'd like to give user a little bit of control over the query that's being executed. So let's go ahead and add a list component. And for the list component, what we'll do is, we'll just close these windows, we'll give some options. So let's say the options are going to be 500, 750, and 1000. And we're going to be changing the percentile of our query using this. So by default, as you can see, it's 500. And what we'll do is we'll actually bind from this value of the currently selected option. Go back to our stage and our data flow. And you can see the SQL query here, it has a hard-coded 1000. So you guessed right, we're going to be linking this list to this parameter. So the first thing to do is to actually make it a parameter. The way we would do this is we're literally going to put a little placeholder in there, and then use a replace block to replace that value with a live value from the list input. So let's go ahead and do that, and let's call this, let's say, curly bracket value. We'll apply it. Now, of course, the query didn't work anymore, and Amazon gave us an error because we haven't replaced this value yet. So now we'll add the replace block, link this string into the replace block, and say that, well, we're looking for this placeholder, and we're going to be replacing it with the value that's coming from the list. So now this output is actually a real query. So when we go to preview mode and we change our dropdown, you can see this query being executed in real time. Of course, we'd like to make this work a little bit better. We can go to the series, go to advanced section, add a little interpolation to the animation. So now when we're changing and the new data updates, we have a nice animated effect. Now there's a lot more table blocks in DGLux where you can do table manipulation. So for example, you can do joins. So you can take this one table. Let's say you're going to bring in some sort of a CSV file and you have a CSV parser, so you can join it with CSV data, or you can add multiple JDBC connections, bring that data together, massage it, and let's say output it as some other value to some other data source, let's say like MQTT or another JDBC connection to be part of another query. So just real quick, I would like to demonstrate how that is accomplished. We're going to go ahead and we're actually going to take our query here, and we're going to create a remote data flow that's going to be outputting for us the sum, the total value, right, as a metric that we can use on our dashboards and pages. So we're creating a remote data flow. Go to its data flow, and we can do the same thing we were doing, but we can actually copy and paste the logic that we had here. So let's just go ahead and just copy these blocks like so, using Control-C, and we're going to paste them directly into the remote data flow. The next thing to do is to actually replace this with a parameter. And what we can do is we can actually define a parameter. So let's say we're going to define a number here, and this is going to be called percentile. And let's say it's going to be 1000 for default, and we're going to link that into the replace. Now that we're getting this output data, what we'd like to do is we'd like to sum this total price column. And the reason we're doing this using blocks is because your data can be coming from multiple data sources, multiple databases. And the data flow is able to take all that data and make it interoperable. So we're going to use a table aggregation block, and we can just link in the sales data column into it. And we're going to look at the column that we want to use. We want to use the total price column. So if we type that in, we can choose the aggregation method. Let's say we want to do sum. So now this is going to be the sum of this data, and we can output this as another block. We can use, let's say, a number here and link that in, and let's call this sum output. If you watched all the other videos, you can guess what we're going to do with this now. Is because we've created this data flow on the server, we actually have all the blocks available to us right here as values and as metrics. So we can actually go ahead and create other components, other charts, and start utilizing this data. And commanding it. So if percentile is going to be changed as a metric, let's say to 500. You're going to see the sum change because internally the query was run on the server, aggregating all the results from one or multiple databases and getting us these results back. Thank you for watching.